Hello everyone, I am Jayarachi Rathore welcoming you in the revision lecture of integration part 2. We will begin from the partial fraction. There is a two condition which must satisfy to apply this method. The first condition is order of polynomial of numerator must be less than order of polynomial of denominator. And second condition is denominator can be converted into factors. जो ना कन्वर्ट થાય तो then we must use ax plus b upon ax square plus bx plus c method. Okay. Now, depending on the factor of denominator, we have to assume proper assumption for partial fraction. The first type of a factor is linear factor, in which power of x as well as power of factor is 1. Then for each factor we have to assume each term. For x minus a we have to assume a upon x minus a. For x plus or minus b we have to assume plus b upon x plus or minus b, and similarly for x plus c we have to assume c upon x plus c. Second factor is quadratic factor. That means the power of variable is equal to 2 or more than 1. Okay. X plus or minus a is your linear factor. So assumption for this factor must be a upon x plus or minus a, and x square plus b square. Due to this x square, we can say this is your quadratic factor. And for that, we have to assume bx plus c upon x square plus b square. Or we can say one less polynomial in the numerator. Okay. Here we have x square. That means it's the second order polynomial. That means in numerator we have to assume first order polynomial. Okay. The another example of quadratic factor is px upon x minus a, which is linear one, and x raised to 4, x square, x and 6. Here we have our denominator in the fourth order polynomial. So we can say our numerator must be third order polynomial. Okay. And the third type of a factor is repeating factor, x plus b whole cube. That means we have 3 repeating factors of x plus b. Okay. And for that we have to assume b upon x plus b, c upon x plus b the whole square, d upon x plus b the whole cube. We have to create the chain of a same factor with increasing power. If we have 4 power, then we have to assume 4 terms. If we have 5 power, then we have to assume 5 terms. So using this assumption, let's try to solve some examples. In this question, we have to integrate 1 upon x plus 1, x plus 2 dot dx. Both are linear factor. So in our first step, we have to assume this 1 upon ax, 1 upon x plus 1 into x plus 2 is equal to, for first factor we have to assume a upon x plus 1, plus for second factor we have to assume b upon x plus 2. Now we have to simplify this thing. Let's take a LCM. So on left side we will get 1, on right side we have to multiply x plus 2 with a into x plus 2, plus x plus 1 will multiply with b into x plus 1, right? Now let's try to find a, and for that the term of b must be 0, and for that let's take x is equal to minus 1. So left side will be 1, and on right side we will get a will as it is. Instead of x we have to put minus 1 plus 2, plus b will be as it is. Instead of x, minus 1 plus 1. So this term will be 0, and we can say our a must be equal to 1. To get the value b, we must get x plus 2 equal to 0, and for that we have to take x is equal to minus 2. So our left side of the equation will be 1, and a into, instead of x we have to put -2, and this b will be as it is, and instead of x we have to put -2 plus 1. Therefore we can get the value of b is equal to -1. So here we complete our second step. Now let's move to the third step, in which we are going to use equation number 1. Let's get our equation number 1. Here we have our equation number 1. Let's integrate both the sides. So on left side we will get our I, and we know the value of a, which is 1 upon x plus 1, and the value of b is -1 upon x plus 2 dot dx. In first term we have 1 upon x plus 1, and its integration will be log mod x plus 1. This -1 is constant, we don't have to worry about it. We just have to integrate 1 upon x plus 2, which is log mod x plus 2 plus c. If you want to further simplify, you can say log mod a minus b will be log a upon log b, or we can say log x plus 1 upon x plus 2 plus c is your final answer. Ta-da! In this question, we have to integrate 3x minus 2 upon x plus 3, which is your linear factor, and x plus 1 the whole square. So step number 1, 3x minus 2 upon x plus 3, x plus 1 the whole square is equal to, for first linear factor we have to assume a upon x plus 3. For x plus 1 the whole square, repeating factor, we have to put b upon x plus 1 plus c upon x plus 1 the whole square. Okay, now we have to take LCM. On left side we will get 3x minus 2 is equal to a into x plus 1 the whole square plus b into x plus 3 into x plus 1 plus c into x plus 3. Now we should move to the second step, in which we have to assume the proper value of x to get value of a, b and c. So let's try to get the value of a, and for that the common factor in rest of the two terms is x plus 3. So to get x plus 3 equal to 0, we have to take x is equal to -3. So our left side will be 3 into -3 minus 2 is equal to a into -3 plus 1 the whole square plus b into 0 plus c into 0. So here we can say your a must be equal to -11/4. Now let's try to get the value of b, but we don't have any common factor in rest of the two terms, right? So right now we cannot find out the value of b. So let's try to get the value of c, and for that the common factor in rest of the two terms is x plus 1. So to get x plus 1 equal to 0, we have to assume x is equal to -1. So on left side we will get 3 minus 1 minus 2 is equal to a into 0 plus b into 0 plus c into -1 plus 3. So we can say the value of c must be equal to -5/2. So we get the value of a as well as c. To get the value of b, we have to take one magical step. We can assume any value of x. So let's assume x is equal to 0. So on left side we will get 3 into 0 minus 2 is equal to a into 1 plus b into 3 into 1 plus c into 3. So let's put the value of a as well as c. So here we'll get -2 is equal to minus 11 by 4 plus 3b plus 3c, or we can say minus 15 by 2. So here we'll get the value of b is equal to 11 by 4. So we get the value of a, b and c. Just put in equation number 1. So let's get our equation number 1. Over here. So let's put the value of a, b and c. Your a is minus 11 by 4. Your b is plus 11 by 4. And your c is minus 5 by 2. So integrate both the side, we will get I on the left side, and on right side we will get minus 11 by 4 is constant, take it outside, we just have to integrate 1 upon x plus 3, plus in second term 11 by 4 will be as it is, we just have to integrate x plus 1, and in third term minus 5 by 2 will be as it is, we just have to integrate x plus 1 raised to minus 2 dot dx. So let's integrate. Minus 11 by 4 will be as it is. Integration of 1 upon x plus 3 will be log mod x plus 3, plus 11 by 4 will be as it is again. Integration of 1 upon x plus 1 will be log mod x plus 1, minus 5 by 2 will be as it is, and x plus 1 raised to minus 2's integration will be x plus 1 raised to minus 1 upon minus 1, plus c is your final answer. Ta-da! In this question, we have to integrate x square plus x plus 1 upon x plus 2, which is your linear factor, and x square plus 1, which is your quadratic factor. Our first step is proper assumption. For first linear factor, we have to assume a upon x plus 2. And for second quadratic factor, we have to assume first order polynomial, which is bx plus c upon x square plus 1. Right? Now, let's take a LCM. On left side, we will get x square plus x plus 1 is equal to a into x square plus 1 plus bx plus c into x plus 2. So we are ready for the second step, in which we have to assume proper value of x. Now let's try to get the value of a, and for that we need to get x plus 2 equal to 0. So let's assume x is equal to minus 2. So on left side we will get minus 2 square will be 4 plus minus 2 plus 1 is equal to a into x square plus 1, or we can say 4 plus 1 plus minus 2b plus c into 0. So here we'll get the value of a is equal to 3 by 5. Now we can find out the value of bx plus b, because x square plus 1 will not 0 for any real number. So let's try to get the value of c by taking x is equal to 0. So this is your magical step to get the value of c, which is x equal to 0. So on left side we will get 1 is equal to a into 0 plus 1. In the multiplication of b, we will get 0 plus c will be as it is, and x plus 2 will become plus 2, right? So here we'll get 1 is equal to a plus 2c. Put the value of a, which is 3 by 5. So we will get c is equal to 1 by 5. So now we have the value of a as well as c. By assuming any value of x, we can get the value of a. So let's take x is equal to 1. So on left side, we will get 1 square plus 1 plus 1. and the multiplication of a we will get 2 plus this b plus c will be as it is and x will be 1 plus 1 or we can say 3. So here we will get 3 is equal to 2a plus 3b plus 3c. Put the value of a and c and you will get the value of b is equal to 2 by 5. So we get the value of a, b and c. Now it's time for the third step in which we are going to use equation number 1. So let's use our equation number 1 and put it over here. Let's put the value of a, b and c. The value of a is 3 by 5. The value of b is 2 by 5 and value of c is 1 by 5. Now it's time to integrate both the sides. So on left side we will get our I and 3 by 5 will be as it is. We just have to integrate x plus 2 dot dx. In second step we have to separate the terms. This 2 by 5 will be as it is. We just have to integrate x upon x square plus 1 dot dx and 1 by 5 integration of 1 upon x square plus 1 dot dx. Now 3 by 5 will be as it is. Integration of 1 upon x plus 2 is log mod x plus 2 plus this 2 by 5 will be as it is. To integrate second term which is x upon x square plus 1, we have to set the differentiation of denominator in the numerator which is 2x, right? And for that let's multiply and divide by 2. So here we'll get 2 by 10 f dash x upon fx. Integration is log mod fx plus this 1 by 5 will be as it is integration of 1 upon x square plus e square is 1 upon a 1 upon 1 tan inverse x by 1 plus c. Ta-da! In this question, we have to integrate x square upon x square plus 1, x square plus 4 dot dx. As you can see here we have two quadratic factors. And second thing, you have to note that we have x square in each factor. Let's assume x square is equal to t for partial fraction. We have to assume t upon t plus 1, t plus 4 is equal to, now t plus 1 is a linear factor, so it will be a upon t plus 1 and t plus 4 is also linear factor, so b upon t plus 4. Before we move to the second step, we have to take a LCM. Our left hand side will be t is equal to a into t plus 4 plus b into t plus 1. Here we complete our first step. Now let's move to the second step in which we have to assume the proper value of t to get the value of a and b. Okay, to get value of a, we need to get t plus 1 equal to 0, and for that we have to take t is equal to minus 1. So on left side we will get minus 1 is equal to a into t plus 4 will become 3 plus b into 0. So we can say the value of a must be minus 1 by 3. Similarly, to get the value of b, we need to take t plus 4 equal to 0. So let's take t is equal to minus 4. So on left side we will get minus 4 is equal to a into 0 plus b into minus 3. So here we'll get b is equal to 4 by 3. So we get the value of a and b. So let's use equation number 1. Let's put t is equal to x square. So our first equation will become x square upon x square plus 1, x square plus 4 is equal to a upon x square plus 1 plus b upon x square plus 4. And we already have the value of a and b. So let's put minus 1 by 3 instead of a and 4 by 3 instead of b. Let's integrate both the side. So on left side we will get I. This 1 by 3 will be as it is. We just have to integrate x square plus 1 dot dx plus 4 by 3 will be as it is, and we have to integrate x square plus 4. Now we know the integration of 1 upon x square plus 1 using the formula of 1 upon x square plus a square. 1 upon 1 tan inverse x by 1 plus 4 by 3 will be as it is, integration of 1 upon x square plus a square. You can say 4 square will be 1 upon a tan inverse x by a plus c is your final answer. Ta-da! In this question, we have to integrate x square plus 1 upon x square minus 5x plus 6 dot dx. As you can see, the power of numerator as well as denominator is same. So we need to reduce the power of numerator. And for that, we need to get x square minus 5x plus 6 into the numerator. Kaise? Let's add and remove minus 5x plus 6. Okay? In numerator, we already have x square plus 1. Let's add and remove minus 5x plus 6. Here we have minus 5x plus 6, and here we have plus 5x minus 6. And you can also use division method for simplification. So here we'll get x square minus 5x plus 6 will be as it is, and x square minus 5x plus 6 individual denominator. So here we can say we have to integrate 1 plus 5x minus 5 upon the factor of x square minus 5x plus 6 will be x minus 3 and x minus 2 dot dx. The integration of 1 will be x, and to integrate second term we have to use partial fraction. So let's use the first step. 5x minus 5 upon x minus 3 x minus 2 is equal to a upon x minus 3 plus b upon x minus 2. Let's take a LCM. 5x minus 5 is equal to a into x minus 2 plus b into x minus 3. Now let's move to the second step. To get the value of a, we need to get x minus 3 equal to 0. So let's assume x is equal to 3. So our left side will be 5 3s are 15 minus 5 is equal to a into 1 plus b into 0. So here we'll get a is equal to 10. Now to get the value of b, we need to get x minus 2 equal to 0, and for that we have to x is equal to 2. So on left side we will get 10 minus 5 is equal to a into 0 plus b into minus 1. So we can say the value of b must be equal to minus 5, right? So we get the value of a and b. So let's use our first equation. Integration of 1 plus, instead of this factor, we have to use a upon x minus 3 plus b upon x minus 2. So let's get over here dot dx. We already have the value of a and b. So instead of a, we have to put 10, and instead of b, we have to put minus 5. Now just integrate. Integration of 1 will be x. This 10 will be as it is. Integration of 1 upon x minus 3 will be log mod x minus 3. And minus 5 will be as it is. Integration of 1 upon x minus 2 will be log mod x minus 2 plus c. Ta-da! This is your final answer. Now, let's move to the next method. Integration by parts. And for that, we have to assume proper function of u and v. Normally, islet is used for it, in which I stands for inverse trigo, L stands for logarithmic term, A is for algebra, and T is for trigonometry, E is for exponential. If we go from the right side, whichever comes first should be assumed as a u, and the next one is assumed as a v, right? In this question, we have to integrate x into cos x dot dx, right? X is a algebraic term and cos x is a trigonometric term. So if we go from the right side, algebra come first and trigonometry will become later one. So we have to assume x as a u and cos x as a v. So let's apply the formula. X will be as it is, integration of cos x dx minus integration of multiplication of d by dx of u, which is your x, and integration of v, which is your cos x dot dx. So x will be as it is, integration of cos x will be sin x minus integration of multiplication of differentiation of x, which is 1, and integration of cos x is sin x. Now this x sin x will be as it is, minus, we just have to integrate sin x. So x sin x still remain as it is, and minus integration of sin x will be minus cos x. So it will become plus cos x plus c is your final answer. Ta-da! Here we have to integrate log x, but we don't have any direct formula of integration of logarithmic term, right? So in this case, integration by parts can be used, and for that we have to consider log x into 1. Log x will be considered as a u and 1 will be considered as a v. And now we have to apply the formula. Log x will be as it is, integration of 1 dot dx minus integration of multiplication of differentiation of u, which is log x, and integration of v, which is 1. Okay, so this log x will be as it is, integration of 1 will be x minus differentiation of log x, which is 1 upon x, into integration of 1 will be x dot dx. This x will cancel out, and x log x will be as it is. We have to focus on integration of 1 only. So still this x log x will be as it is, and integration of 1 will be x plus c. If you want, you can take x common. So here we'll get log x minus 1 plus c as your final answer. Ta-da! So partial fraction is also used for integrating logarithmic term and inverse trigo terms. In this question, we have to integrate x into e raised to x dot dx. X is your algebraic term and e raised to x is your exponential term. So algebraic term will be considered as a u and exponential term will be considered as a v. So let's apply the formula of partial fraction. Your u will be as it is, integration of e raised to x dx minus, we have to integrate multiplication of differentiation of u, which is x, into integration of v, which is e raised to x. Now x will be as it is, integration of e raised to x will be e raised to x minus differentiation of x will be 1 and integration of e raised to x will be e raised to x dot dx, right? So this x into e raised to x will be as it is minus, we just have to integrate e raised to x once e raised to x. So still x into e raised to x will be as it is. Integration of e raised to x is e raised to x plus c. If you want, you can take e raised to x common. E raised to x into x minus 1 plus c. Tada! This is your final answer. In this question, we have to integrate x into sine inverse x upon under root of 1 minus x square dot dx. The integration contain inverse trigonometry. મને જરાય પસંદ નહીં. So I always prefer to assume this inverse trigonometry is equal to t. Let's assume sine inverse x is equal to t. And don't forget to write down that t is belongs to 0 to pi by 2. Now differentiate both the side. We will get 1 upon under root of 1 minus x square dot dx will become your dt. So now we can modify our integration as this x can be write as a sine t and this sine inverse x will be t and dx upon under root of 1 minus x square will become your dt. Sine t is your trigonometric term and t is your algebraic term. So you have to consider t as a u and sine t as a v. So we are ready to apply the formula. Your u will be as it is. We have to integrate sine t dt minus we have to integrate multiplication of differentiation of t and integration of sine t. So this t will be as it is. Integration of sine t will be minus cos t minus we have to integrate differentiation of t which is 1 and integration of sine t which is minus cos t dot dt. Now first term will be as it is minus t cos t and this minus will be taking outside will get plus integration of cos t ones are cos t dot dt. So this minus t cos t will be as it is. Integration of cos t will be sine t plus c and don't forget to put the value of t. Sine inverse x is equal to t, or we can say we have sine t is equal to x. Let's use triangle method. If we consider this as a t, then x upon 1 opposite upon hypotenuse. So adjacent must be 1 minus x square, which will give us the value of cos t adjacent upon hypotenuse. So let's put the values. Minus, instead of t we have to put sine inverse x. Instead of cos t we have to put under root 1 minus x square plus instead of sine t we have to put x plus c. This is your final answer. Tada! In this question we have to integrate e raised to x into sine x. E raised to x is your exponential term and sine x is your trigonometric term. So we have to consider sine x as your u and e raised to x as your v. So let's apply the formula. Your u will be as it is. integration of e raised to x is e raised to x minus, we have to integrate multiplication of differentiation of sin x is cos x into integration of e raised to x, which is e raised to x dot dx, right? Now this e raised to x sin x will be as it is, and here we have integration of cos x e raised to x. Again we have two terms in multiplication. First one is trigonometry and second one is exponential. So trigonometric term should be assumed as a u and exponential term considered as a v. E raised to x sin x still remain as it is. We have to focus on this integration. Our u will be as it is, cos x will be as it is. Integration of e raised to x will be e raised to x minus, we are going to integrate multiplication of differentiation of u, which is minus sin x, and integration of e raised to x, which is e raised to x dot dx. So here we get I is equal to this e raised to x sin x still remain as it is. If we apply minus 1 within the bracket, we will get minus e raised to x cos x minus integration of e raised to x sin x dot dx, which is your question. So let's take e raised to x common from the first two terms. We'll get e raised to x, remaining term are sin x minus cos x minus this integration of e raised to x sin x is your I. So if we take this I on the left side, we will get 2y is equal to e raised to x sin x minus cos x, or we can say your I is nothing but e raised to x by 2 sin x minus cos x plus c as your final answer. Ta-da! In this section, we have to recall the formula integration of e raised to x into fx plus f dash x is nothing but e raised to x fx. If we have differentiation of any function in addition, we just have to ignore that differentiating term and you will get your integration. Let's try to solve some examples. In this question, you have to integrate e raised to x tan inverse x plus 1 upon 1 plus x square dot dx. So we have e raised to x. We just have to check which one is your function and it's your differentiation. So it's observable that your tan inverse x is your fx and 1 upon 1 plus x square is your f dash x. So according to formula, we just have to ignore the term of f dash x and your integration is done. That means e raised to x tan inverse x plus c is your answer. Ta-da! So this is your easy peasy sum. Let's try to solve next question, in which we have to integrate e raised to x square plus 1 upon x plus 1 the whole square. Here we have e raised to x. So we should separate our numerator in such a way that we get fx into f dash x form. So let's add and remove 1, minus 1 and plus 1. Okay, and we just have to take individual denominator. So e raised to x still remain as it is. This x square minus 1 will become x minus 1 and x plus 1, and denominator will be as it is, and 1 plus 1 will become 2 upon x plus 1 the whole square will be as it is. Now as you can see, 1 power of x plus 1 will cancel out from the numerator as well as denominator. So here we get e raised to x within the bracket we have x minus 1, x plus 1 plus 2 upon x plus 1, the whole square will be as it is. Now let's check we have the differentiation of fx or not. So let's consider this is your f of x, and let's check 2 upon x plus 1 the whole square is f dash x or not. So f dash x is nothing but d by dx of x minus 1 upon x plus 1. We have to use division rule, in which x plus 1 will be as differentiation of x minus 1 will be 1 minus x minus 1 will be as it is, differentiation of x plus 1 will be 1 whole divided by x plus 1 the whole square. X will cancel out, we will get 1 plus 1 is equal to 2 upon x plus 1 the whole square will be as it is. So yes, the second term is your f dash x. So here we have e raised to x fx plus f dash x form. We just have to ignore the term of f dash x and we get our answer. That means e raised to x within the bracket x minus 1 upon x plus 1 plus c is your final answer. Ta-da!